Alright, hi Year 11s, and this is Mr. Lim here again. This is another video on AQS solutions, and we're going to be doing grams per liter. So let's get started. Alright, we're going to do some more math. Alright, so it's effectively a concentration unit where you're working out the mass of something per number of liters. Alright, it's very similar to moles per liter, but instead of it being moles, we're doing grams. So we're just going to jump straight into some examples. So let's have a look. You've got the concentration of sodium hydroxide in grams per liter that had 53 grams of 76.5% pure sodium hydroxide added to 400 mils of water. Okay, so there's a little bit of an extra tickle here because it's got the 76.5 percentage. Okay, so let's go through and let's work out how to do this. So first of all, we might have to work out how much sodium hydroxide is actually here. So the mass of the sodium hydroxide pure, because we've only got the impure mass, the 53 grams, is 53 times the 76.5 over 100. Okay, what this is actually showing is that this is effectively the mass of the total, right? That's the impure and pure, right? Times the percentage over 100, which is a rearrangement of the equation. Percentage is equal to mass of the pure over the mass of the total times 100. Okay, so if you rearrange that equation, you'll get this one over here. All right, so that's the logic behind there. So hopefully you can follow along with that. And that's going to be 40.545 grams. Okay, once you've got the mass there, you can work out the concentration. So the concentration of NaOH will be equal to mass over volume, okay, because it's similar to N on V, but instead of N, we're doing M for mass, which would be 40.545 over the 0.4, because remember we need this in liters, right, which will be equal to 101.36 grams per liter. All right, so nice and straightforward. How many grams in how many mils of water, how many liters of water? Okay, let's move on. Okay, so convert moles per liter to grams per liter. So we're looking at what's the concentration in grams per liter of a 0.5 mole per liter lithium nitrate. So the idea is that you've only been given a concentration here. So because we want to find out the concentration of both of them in the same thing, we can just assume a certain volume. Assume volume equals 1 liter, because effectively you're saying what's the concentration of the same solution in of the same stuff, but then you just need to give some sort of value to work that out, right? So we're just going to choose 1, and so that we can work out, okay, what's the number of moles of lithium nitrate? All right, so if it's 1 mole per liter, or sorry, if it's 0.5 mole per liter and we got 1 liter, it's 0.5 moles. That makes nice and sense. All right, let's have a look. Next, we need to work out the mass of this lithium nitrate. Okay, so how do we work out the mass? Well, we take that, we would do N times big M, which is effectively 0.5 times 68.95, which is the molar mass of lithium nitrate, and you'll get 34.48 grams. Okay, once you get that 34.48, you can work out the concentration. The concentration of the lithium nitrate is equal to 34.48 over 1, which is equal to 34.48 grams per liter. All right, nice and simple. Okay, next one. Okay, next, determine the volume of solution required to have 4.2 moles of calcium ions from a 15 gram per liter solution of calcium nitrate. So the idea is that, first of all, we require calcium ions. How many? 4.2 moles. Okay, so we're going to get those calcium ions from calcium nitrate. So the number of moles of calcium nitrate and its relationship to the number of moles of calcium will be 1:1. Right, so we're timesing that by 1. So we're showing that we need 4.2 moles of calcium nitrate. Okay, because we have calcium nitrate solution. That's why we have to do things in calcium nitrate. So then you can work out what's the mass of calcium nitrate required. Because if we can work out the mass, we can work out how many liters we need to get that mass. Okay, so we will take that 4.2. So this is the number of moles times the molar mass, which is 4.2 times 164.1, which happens to be 689.22 grams. Okay, so that's the mass of calcium nitrate we require. Now, if 15 grams is in every liter, we're going to need quite a few liters. So the volume of calcium nitrate required will be equal to M on C, right? It's the mass over the concentration. So we require 689.22 grams, and we've got 15 grams per liter. So therefore, I'm going to need 45.95 liters. Okay, and that makes sense. To try and get 600 or so, you need quite a bit of liters of this stuff. All right, next. So this is a limiting reagent, but one of them we've got a grams per liter. Okay, so we've got 15 mils of 41 grams per liter sodium hydroxide, and we've got 20 mils of 2.4 mole per liter hydrochloric acid. All right, with the following equation, what's the equation? This is the equation. Hydrochloric acid plus sodium hydroxide goes to water and sodium chloride. Okay, and that's balanced already. So now we have to determine the limiting reagent. So first of all, we'll go start with the sodium hydroxide. So we're going to work out the mass of sodium hydroxide that we have in that 15 mils. All right, so in that 15 mils, we have CV, we have the concentration times the volume. So it would be 41 grams per liter times how many liters we have, which is 0.015, which happens to be 0.615 grams. That's the amount of sodium hydroxide that we have. All right, now that we've got that, we can start working on the number of moles of hydrochloric acid. So the number of mole, oh wait, no we don't. We want to work out the number of moles of sodium hydroxide that we have. So now that we've got the mass, we can work out the moles. Okay, which will be equal to mass over molar mass, which is equal to 0.615 over the molar mass of sodium hydroxide, which happens to be 39.998, which happens to be 0.01538 mole. Okay, I'm going to save that as A because you should always save your numbers. Now we're going to work on the hydrochloric acid. So the number of moles of hydrochloric acid, okay, is equal to CV. But this time we've got 2.4 as a moles per liter times the 20 mils that we've got, which happens to be 0.048 moles. Okay, so we go straight to moles and we save that as B. All right, so the number of moles, and we'll just do this in black, the number of moles of, let's just do HCl needed, is equal to the number of moles of NaOH that you have times 1 on 1. This is stoichiometry, okay, based on the balanced equation, which is equal to A. Okay, once we know that, we can say that, okay, how much hydrochloric acid do we need compared to how much hydrochloric acid we have? So we're comparing this number with this number, and the amount that we have is much more than we need, right? So that's how much we have compared to how much we need. Actually, it's this one there, but it's the same number. All right, so we have much more than we need, right? Therefore, the sodium hydroxide is the limiting reagent. Okay, last one. Let's go through one more. What mass of impure substance is required for a certain concentration? So therefore, if we ever calculate the mass of 48% pure copper sulfate solid that is required to be dissolved in 400 mils of water to make a 48 grams per liter solution. So the idea is that our copper sulfate solid is not pure. 50 or 40%, 48% of it is impurities, and the rest of it is copper sulfate, right? But we know that that's only 48% pure, so we should be able to work out how much of that stuff we need to make it a 48 gram per liter solution, right? So, and remember we only need it in 400 mils of water, so let's get started. So the mass of copper sulfate pure that we need is equal to 48, or let's do this, C times V. Effectively, how many grams do we need of this copper sulfate? All right, so we need 48 grams per liter, but we only have 0.4 liters. So therefore, we need 19.2 grams. So that's how many grams of copper sulfate that we need. All right, we're going to get that from the impure copper sulfate. Right, so the mass of copper sulfate impure that we require will be equal to, we need 19.2 grams, and we're going to get it from the impure thing, so we need to do 100 over 48, which is effectively a rearrangement of the equation of percentage is equal to mass of pure over mass of impure times 100. And the idea is that, okay, what have we got? We got percentage, that's here. We've got mass of pure, that's what we've got here. We've got the mass of impure, which we're actually solving for, and we've got the 100. Okay, and so when you rearrange those two equations, you'll get the exact same thing, right? So that's how we come across that particular equation. So what do we need to do? We do that calculation and we get 40 grams. Okay, so those are some general equations that you might, reactions or calculations that you might do with grams per liter. Effectively, you will need to bring it into moles lots of the time, but that's just something we have to know how to do. And that's it. Adios.